So the motion of the moon around the earth is due to centripetal force, and the centripetal force is exerted by the earth. That means the force of attraction exerted by the earth on the moon. Is it clear? So the centripetal force acting on the moon is the force of attraction exerted by the earth. If there is no such attractive force, or if the earth didn't apply any force on the moon, what will happen to the moon? The moon will go along a straight line. Isn't it? You already know, when we whirl the stone by tying it on a string, it moves along a circular path, and when it releases, what will happen? It moves along the tangent. That means it moves along a straight line. So what is tangent? Tangent means it is a straight line passing through one point on the circle. That means each and every point has its own tangent. So when we release the object at each point, it moves along the tangent at that point. We already know each and every point on the circle lies on different plane. So, and each and every point has its own tangent. So it moves along the straight line or along the tangent at that point. So likewise, if there is no centripetal force acting on the moon, then the moon has to travel, or moon will move along the straight line. So here we can say that earth is attracting the moon, or earth applies centripetal force on the moon. Okay, now in the case of apple, if the earth applies force on the apple, does the apple apply force on the earth? If so, why we do not see any movement of earth towards apple? That we can explain based on the third law and second law. According to third law, we can say that every object, that means for every action there will be equal and opposite reaction. According to third law, for every action there will be equal and opposite reaction. So if earth applies force on apple, apple also should apply equivalent force on the earth. Isn't it? But based on the second law, what is the mathematical expression for second law? F is equal to ma. Isn't it? F equals ma. So here according to third law, these two forces are equal and opposite. According to third law, the force applied by the apple on the earth and the force applied by the earth on apple, both are equal and opposite. So force is constant. Okay, force is constant. So what is the relation between mass and acceleration? If we are taking force as a constant term, so we can write the equation A is equal to F by M. F is equal to ma. So A is equal to F by M. Isn't it? A is equal to F by M. So if force is constant, we can write A proportional to 1 by M. That means acceleration inversely proportional to mass. What does it mean? Acceleration inversely proportional to mass. What does it mean? As the mass increases, acceleration decreases. As mass decreases, acceleration increases. Okay, so here when we compare the mass of apple and earth, apple's mass is negligibly small when compared to the mass of earth. So in order to equalize the force, acceleration of apple should be much greater than the acceleration of the earth. Is it clear? Acceleration of apple should be much greater than acceleration of earth. So when the earth start to move, the apple will reach on the surface of earth. During that time itself, apple will reach on the surface of earth. So we cannot see any movement of earth. Is it clear? Because earth has very huge mass compared to the small apple. So acceleration of apple is much greater than the acceleration of the earth. That means even the earth starts to move, move, before that itself apple will reach on the surface of earth. Is it clear? So this is also a very important question. So according to third law, for every action there will be equal and opposite reaction. So if apple applies the force on earth, earth also will apply force on the earth, and that will be equal. So force are equal, but they are in opposite direction. According to second law, we can say F equals ma, isn't it? So if we can write A is equal to F by m. If force is constant, we can remove that constant and we can write with the proportional sign. A proportional to 1 by m. As mass increases, acceleration decreases. So in the case of Earth, acceleration is very small compared to the acceleration of apple, because mass of Earth is huge, isn't it, compared to mass of apple. That means apple's mass is negligibly small. Okay, that is why when the Earth when the Earth tries to move, the apple will reach on the surface of Earth. Is it clear? Now, based on all these observations, Sir Isaac Newton derived a law. That law, or state a law. That law is known as universal law of gravitation. All these things, he concluded that every object in the universe attracts each other. Every object in the universe attracts each other. That means we are also attracting each other, and that force is known as gravitational force. That force is known as gravitational force. And Earth's gravitational force, we call it as gravity also. So then, Earth's gravitational force, we call it as gravity. So every object in the universe attracts each other. That means even we are also attracting other objects. Other objects also attracting us. Likewise, every object in the universe attracts each other. And that force is directly proportional to the square of the distance directly proportional to the product of two masses. That force is directly proportional to the product of two masses. When we consider only two objects, it is directly proportional to the product of two masses and inversely proportional to square of the distance between them. Inversely proportional to the square of the distance between them. That we can discuss later. So, here I told every object in the universe attracts each other. Isn't it? And I told you all the objects around us also attracts each other. So why we are not colliding each other? Why we are colliding each other? Even the bench or desk or bag, books, everything are there, and we are all attracting each other. Even the persons, they can also attract each other. Why we are not colliding each other then? We are living on the surface of Earth. Earth attracts every object towards its center, isn't it? And our mass is very less, isn't it? And when we attract force on other objects, that for gravitational force is very less compared to the gravitational force between Earth and our body. So we are firmly stick to the Earth, isn't it? So that is why we are not colliding each other. They are also firmly stick to the Earth. So our gravitational force between any objects are negligibly small compared to the gravitational force between our body and the Earth. Is it clear? Our gravitational force between Earth and our body is far greater than the gravitational force between any objects and us. Is it clear? So that is why we are not colliding each other. Got it what I said? So when two persons are attracting each other, their masses are very less. So according to that, their gravitational force is also very less. But the huge attraction between or large magnitude of attraction between Earth and our body is there, isn't it? So that is so strong when compared to the gravitational force between two persons. That is why all the objects are stick to the surface of Earth and they are not colliding each other. Is it clear?